Can everyone see the screens, the slides?
Yep.
Dope. Okay, I think we're recording. I'll get started. All right, authentication, authorization. So yeah, before we get into that, I'll give a quick, opening to like why this is important. So obviously, authentication and authorization are important for all the obvious reasons, as in like users want to be able to see their own accounts. They want to get access to your service, stuff like that. And there's also like a bunch of like really important reasons, right? So like you could keep really important data for users. So if you're a financial service or a bank or anything like that, you have access to a lot of users' really, really important information that if it gets out or is given to the wrong person, doesn't work correctly, that is really, really bad news, not just for you, but also for all of your users. So authentication and authorization are super important. In the past, we've done our kind of own in-house authentication authorization. We might be moving to a bit of a more common authorization and authentication services that are like published by Google and Amazon, things like that, because those guys get paid a lot more than we do to implement those things, and they do it really, really well. But I'm here today to give you guys more of an overview on how authentication and authorization works as a whole, and how it kind of fits into the tech stack, what kind of services are out there, and what the entire process really looks like. So without further ado, about just these are going to be basic authentication and authorization workflows. So a lot of these things you're not going to understand what I'm saying, but hopefully you will understand what this means once we get through the end of this presentation. But really quickly, there's three main parts to authentication and authorization. There's the login part, and then there's access tokens and refresh tokens. So this is called a token-based authentication service, and this process is used it's used pretty much everywhere these days. All like these web applications, mobile applications, server-side applications, authentication like this form of authentication called token-based authentication is really, really popular these days and is super useful.
Especially on mobile, right? Web sometimes can use like cookies and stuff with tokens as well, but mobile
Yeah.
is pretty much always just tokens.
Yeah, so mobile is 100% just tokens because there's not really such things called cookies because we don't have a browser in the web in the mobile. Web, you have cookies as well. They works almost identically to token based, just like pure tokens, which are called JSON web tokens. They're most popular, but we'll get into that later. So authentication authorization, you start with the login step. Pretty simply, you just verify that these users exist and make sure that they're able to log into their own data and information. Then you have things called access tokens and refresh tokens. Um, so access tokens are essentially what a server returns to any kind of service or any kind of application that logs in correctly. So if you're a user and you log in, you're going to get an access token back. This access token will allow you to make HTTP requests to APIs. Will allow you to. It's like the ideal way that mobile and web front end services work is that they receive an access token and use it to make an HTTP request to an API, to a database, to some sort of backend service. And then this access token is the proof that they have the correct permissions to actually receive data or post data to whatever backend structure you're using. Additionally, you have something called refresh tokens, which allow you to get new access tokens once your access tokens have expired. Because access tokens are really short lifespan. With really short, that can be anywhere from 30 seconds to 5 minutes to maybe even an hour. But they're literally that short on a like pretty general basis. Refresh tokens are typically they're at minimum as short as an access token, but usually longer than that, anywhere from usually around 6 hours to 24 hours to even a week long. Refresh tokens are all things that are used in the industry right now. So what do all these things mean? What does it do? Let's go talk about that a little bit more. So what is authentication? So authentication essentially helps any service answer the question, who are you? So authentication helps you verify who a user is, and it's always the first step in this process. So for an example, a user has access to secure credentials like a password, answers to security questions, and even facial or biometric recognition these days. So these are all credentials that are things that only a user should know or have access to, which means it's proof of them being a certain individual. Now, an example of an authentication service or an implementation of authentication are things like single sign-on, multi-factor authentication, and normal password-based authentication. So all of these login types allow a user with certain credentials to prove that they are who they are. And allows this backend service, whatever server you are talking to or using, allows you to make sure that a user gets data that's relevant to them, and allows you to be really certain about who a user is. Any questions on like what the concept of authentication is, or any examples? All right. So let's talk a little bit about like some real world examples. So I'm a huge fan of the Spotify authentication flow. The authentication flow is really clean, really well fleshed out, and great documentation behind it. And so this is half of the example of how their entire authentication authorization flow works. And we'll go over the rest of the example once we learn more about authorization. But very simply here, in the Spotify example for authentication, any application that wants to access the Spotify account service. So this would be the Spotify account service would be your backend. Your application you can consider as yourself or your front end. In order to request authorization, they use the word authorization here in lieu of both authentication and authorization. But as you can see, they're requesting access. And so once they request access, the Spotify account service, will prompt the user to log in. A user who's using your front end would then log in and authorize access to their Spotify service. Now, once they've done that, your application must also request access and refresh tokens. And once they get these access and refresh tokens, they can go on to the next steps of getting data, changing data, and things like that. Tiago, somebody has messaged in general. If you want to take care of that. So authentication. So this is a pretty, I kind of made this pretty simple, but the authentication for Spotify works is that you request access to a backend service. The user must give you access, and then you must also request your access and refresh tokens. Any questions on what this seems like? Okay, cool. So let's talk about authorization now. So authorization is this idea of, we have verified that you are a user and that you exist, and we know who you are. But what are you allowed to do? So authorization has to do a lot more with permissions and roles. So there's different types of users in any service: admin users, free users, paid users, and even within those, there's a lot more specific situations, right? They could be, if you think about any kind of subscription model, where they could be, a new user, first-time user. They could be a long-time user or someone who's just recently upgraded to like the paid tier plan. Like there's a bunch of different tiers. And so all these users need to have access to different things. They also need to be able to access different types of data, different databases perhaps, or call different functions and things like that. Now, authorization is managed by the application and can be changed independently of authentication. So what that means is if you need to change a role, for example, if you're upgrading from a free tier to a paid tier or a paid tier to a free tier, all that is handled independently of who you are. So who you are and what you're allowed to do are very connected and they're dependent of each other, but they can be manipulated more independently. And this is really important because this is kind of the foundation of how our authorization and authentication services work in the industry. So when somebody logs in, that's its own kind of entity of making sure that they're able to get access to the data they need to get access. And then what they can do is the second part of that of authorization, and that they should only be allowed to touch things and access things that their user has permissions to do so. Right. So let's revisit this Spotify example and kind of see what the whole thing looks like now. That if you had made some kind of front end application that would allow you to, that you need access to Spotify account service for some reason. So again, we can see at the beginning that we request access to a data and have the user log in to authorize access. Once we request access and refresh tokens and actually get them back from the Spotify account service, we can now use the access tokens to we add them to our web, like our HTTP request that we access the Spotify web API with. And those access tokens are proof of our roles. They're proof of our credentials and things like that. They're proof that we deserve access to the Spotify Web API, and we would deserve access to whatever data we're requesting and whatever data we want to manipulate, change, or delete. And so we use these access tokens in request to the Web API for as long as those access tokens are available for as long as they're valid. Once the access token has expired, we must now use the refresh token to request a new access token. So if we look a little bit more closely at this workflow is essentially saying that we use our access token in request to our web API, and we continue to go back and forth by using our access token for request and getting data back. And then once we oh, this looks like it's a bit outdated. Apologies. I probably should have got a better picture, but it's supposed to say uses the refresh token in our request to the web API, and so we can get a new access token. And so essentially every time our access token has expired, because it's only available for a short amount of time, because it does give us unlimited access to whatever permissions we have asked for, we need to make sure that nothing has changed since the last time we've given an access token with a user. For example, if they've logged out or if they've changed like their role, if they don't deserve those roles anymore, if they revoke permissions or anything like that. And so that's the reason why access tokens are so short-lived, because things can change like when somebody is on any kind of like platform, and if they do change, we want to make sure that they still deserve access to whatever application we're using. So in a mobile yeah, so I'll talk about security aspects in a sec. But so if we imagine this in a mobile standpoint and how this works, because a lot of you guys are working with mobile apps, this is pretty simple to do because you guys have a lot of navigation tools and stuff that allow you to deny or go to pages at different points. And so if you now keep these access and refresh tokens in your persistent storage on your mobile device, in your state, or any kind of other storage, like short-term storage that you have on your mobile app, you're able to continuously reuse these access tokens and refresh tokens for as long as a user wants to continue being logged into an app, and it doesn't force them to re-log in every time they open the app. They might like be continuously logged in for like the next week or for the next day or two, in whichever way you want to do it. And so this workflow and this authentication flow is really the standard with most backend services these days. And so when you want to connect your front end to your back end with a certain user, this is how you are probably going to do so, depending on whatever API you use or your own databases in general. So what that means is if you're in your own apps, and what we have written in our most TPO repositories right now are lambdas in our AWS console and in our front end request functions in our GitHub repositories that will allow you to request access tokens, request refresh tokens, and make HTTP requests with the specific access tokens that our lambdas or your lambdas should check. And so if you guys want to go see that documentation, talk to your engineers on your projects and go see exactly how we have that set up in our AWS console right now, and see exactly what kind of access tokens and refresh tokens we're returning. Now, I want to talk to you guys a little bit about the security aspects, because when you guys go and read these functions, you'll see that they are really a bit complicated. They're pretty verbose in how much stuff is written there. And I'll explain a bit why we've written these functions the way we have. And it's all because of security. So there's a lot of security aspects that are really, really important towards authentication and authorization, as you guys can probably imagine, especially when you think about financial data or any kind of secure data like social security numbers and things like that. People should only have access to data they deserve to have access to. So when we're making our own apps, even if it's not the most important thing, like maybe it's about student government or something like that, like when I say most important, I mean like the most important to keep secure. But we're also doing stuff with Dell Medical and Dell Children's Medical, and so like those are that's data that's protected by HIPAA and laws that are really, really secure around those things. So we need to be very, very careful with the people we're giving access to. And so you're going to see all three of these things, these salting, hashing, and encryption aspects in our AWS Lambda functions. And so what's really important so it's really important for me to try and explain to you what these ideas and concepts are, so that way you don't feel like you don't understand what's going on. So I'll talk to you guys first about what hashing is. So hashing is the idea that maps that kind of is behind what a hash table or a dictionary in Python is. And so it takes any amount of data and it'll map it to an exact fixed length. And so this will make everything of the exact same format. So think about all of your plain text passwords, like any kind of password that has all these restrictions or whatever. It's going to, a hashing function will take any of those passwords or username, well, mostly passwords, you really will take any of those passwords. It will apply a function to it that will then return some kind of data of fixed length. So the password, the in plain text password, if it's applied to a hashing function, would return this string of numbers 2389473298848, which could have to do with people's like the amount of bytes that are in there, combined with the length of the data, combined with how many uppercase P's are in there. It's a lot of random things you add into it that makes it an irreversible function. That if you give someone a string of numbers, they'll never be able to understand that it came from password. And that's the entire idea, is that you are I always mess up this word, but it's I don't know how to say it. It's how it's.
What's the word?
I'm gonna type it in here. Obfuscating.
Obfuscate. Is it just obfuscating?
I think so. I just never say it correctly. But it's this idea of how you can do that to any kind of plain text password. So that way, even if your databases are leaked, even if you have some kind of employee who's like somehow printing out all of the databases of passwords and stuff, they will never, if these get online, you can still not figure out what a person's password is because it's been hashed into something that's irreversible. Which means they can never get back to the plain text password that it originally was in. So you should never, ever store plain text passwords. You should always hash them before you store them. And so the hashing technique that is used most commonly is called SHA, and it returns a string of, like a number of set length. Very importantly, SHA-1 is not secure anymore. And so you should use SHA-2 with 256-bit encryption. If you don't know what any of that means, that's not a really big problem. It's not something you need to think about too much. But if you are ever implementing these in the future and doing that research, like SHA-2 is what's important. You have to use SHA-2 because it is secure, where SHA-1 was found to be not secure. Okay, now I'll talk to you guys about salting. So salting is this idea. Give me 1 second. Let me put my computer on do not disturb. Okay, so salting is this idea of even if your hash function is somehow broken, what if we add random values and strings and letters to everybody's password, so that way even if the hash value has been broken somehow, they're still not going to know what the original plain text password was. And so why that people would do that is if somebody uses a bad or a normal password, they still are not going to be able to get access to a database just by using a brute force attack. And so what a brute force attack is that they have a giant list of, it's called a word list usually, which is obviously, as you can tell, a list of words that are probably the 10,000 or 100,000 or even a million most common passwords that could be used. And they will try every single one of these passwords against the database. And so why some people would use salting is that, for some reason, if the database is leaked and the hash function is somehow broken, they're still not going to get the correct password, because before the password is hashed, before it's applied to the hashing function, we're going to add some random letters to every single password. So that way it's going to actually change what the password was originally. And so if we take a look at what this would look like, if someone's password was the word password, we're going to actually change that password when they input it to this new string that says password123salt. And then that hash value is going to be something different. So this is obviously on a small scale like this, it doesn't seem like it would, like it's pretty obvious that the password would still be password or something like that. But salting can be used in any sort of way. And there can even be randomness added to it, which some companies and some security companies do, where they add randomness to it so that even if you did know the original salting password, you would still have to go through a more brute force of trying a bunch of different various combinations of random letters added to any single password they might think. And so if you think about this on a dimensionality, if you have a dictionary of 100,000 different possible passwords, and then you also get this additional additional thing to check of what if everything also has an exclamation point at the end and has the letters 2 and 3 in it randomly anywhere in the entire password. It then becomes so much harder to test every single one of those passwords with all of those combinations and all that criteria added on it. And the password, usually the hackers don't even know what the salting is. So they're trying what common salting techniques. So they're saying maybe it has 2, 3 letters in it. Maybe it has the number 6 in it. Maybe it has an exclamation point in it. And so it just becomes more and more difficult for anybody to get access to your database or impersonate a user or anything like that. And now the very last thing we talk about is encryption. And so this encryption is how you're going to send data from one place to another. So now that you've hashed your password and salted your password, that's great and all, but you still don't want anybody to be able to intercept that information while it's going from your front end to your back end, because HTTP requests are not secure. HTTP requests could be intercepted over any Wi-Fi network, and that's like kind of why they're great, is that they're really efficient and easy to use, and they don't require any authentication. But what that means is that you do need to encrypt the data that's being sent through them. So encryption always uses something called an algorithm or a cipher, also called an encryption key, that will take any kind of data sent in it and encrypt it in a certain way. So this could be your password, this could be your endpoint, this could be your username or email. All of these things should be encrypted and before they're sent through an HTTP request. And the best way that encryption is used today is in a way called private key, public key. And what that means is every database or backend structure will have its own private key that is going to be able to decrypt anything that's being sent to it. And there's a paired public key. So private and public keys come in pairs, one private key, one public key, where the public key is used to encrypt something. So the public key is the encryption key in this situation, and the private key is the only thing that can decrypt that. Because this way, only the backend service will be able to decrypt whatever data you've been sent to it, because you've encrypted it with the public key it's been sent to you. And there's a number of different ways that people do this, but the most popular ones are RSA and AES. RSA is based on factorization of primes, and AES, I kind of forget, but there's another, it's also a mathematical algorithm. And so specifically RSA deals with the most powerful one is 250, or the most common powerful one is 256-bit primes, because those kind of passwords or that kind of encryption, it will take over 1 billion years to crack even one RSA key. One key that's been encrypted with RSA 256-bit encryption. So these private key, public key things are really common for SSL and SSO and things like that. So these are all like secure signing keys and logins and different methods that people use to log into websites, banks, mobile apps, and things like that. So hopefully now, if you read any of our lambdas, or if you are going into authentication, doing it later on, you make sure to think about hashing, salting, encryption, and make sure to do them correctly. Because if you don't, it exposes a lot of data that's not good. Okay. So let's talk about. Did I skip one? Oh, we missed passing it. Okay. So we talked about. I talked about a little bit about how Amazon and Google are working on things. I mean, they have people who are actually paid a lot of money to work on build these things out for us. So Amazon Cognito is something that we're probably going to maybe try and push you guys towards. Thiago probably we need to talk to Jonathan and stuff about that, but we might be pushing you guys towards Amazon Cognito. So kind of a heads up about what it is. It's an all-in-one authentication and authorization service for all of AWS services. So which means is you're going to talk to Amazon Cognito anytime you want to talk, mess with databases, logs, like anything else you're using on Amazon, like your Lambdas as well. And so what's really nice is that Amazon Cognito has been built really well, and it's made to be super easy to add on to any existing mobile apps. So if you go to, obviously this will be in the slide, but um, Amplify like documentation contains the information about the documentation about Amazon Cognito you guys need to use. And so, like as you can see, it has documentation specifically for React Native and Expo even as well. So, which means that it should make all of your life a lot easier to actually like implement these things when if we decide we want to for in the future. And what's really nice about Amazon Cognito, AWS Amplify, and Google Firebase, all these services that do like this all-in-one kind of thing for you, is that it's all been tested and it's all secure by Google and AWS. So like you don't have to worry about whether your hashing function, your salting function, your encryption is secure or good enough, or if there are any security holes in your features. There's a well-tested, well-documented procedure that you guys will use to authenticate and keep data on users, and as well as authorize HTTP requests and things of the sort. So hopefully this documentation is going to be super helpful. And if we need to do more, maybe we can do more lecture on exactly how to use AWS Amplify and Google Firebase in the future. But for now, going to move on to some more information about how authorization works. So you might have heard Tiago talk earlier about like cookies and tokens and things like that. He mentioned that a little bit. But I'm going to talk to you guys about what the most popular token-based authentication method is, and that's to use something called JSON Web Tokens. So JWTs, which is the short form, are essentially JSON formatted like JSON formatted tokens that you use for your authorization. And so what this means is that you don't have to rely on the back end to continuously, sorry, let me rephrase what I was talking about. So JSON Web Tokens are super helpful, right? So as a token, authorization tokens are added to every HTTP request in order for you to make gets, make posts, and deletes and things of the sort. And so JSON Web Tokens contain information, including the user ID, the name, as well as the expiration time. So you can you can realize that JSON Web Tokens are just a format for how your authorization, your access and refresh tokens are. So it's just a format for how they are and a format for how they're stored. And what like tokens in general help you do is that they eliminate the need for a backend server to make a query to get a database, a query to a database to get the user info. So if you provide all of the user information inside of the JSON Web Token already, then the backend has all of its information it needs in order to make your HTTP request. If you don't use something like a JSON Web Token and you use something that's like a really simple token that just says, here is my user ID, it first has to make a database query in order to go get all of your necessary user information from the user table. But the JSON Web Token format will allow you to keep all necessary information about a user inside the payload of the token, and it minimizes the amount of database requests you need to make. The last thing that's really important is that it also contains a signature, which would help prevent any attackers or hackers from forging JSON Web Tokens on a user's behalf. For example, something that they would want to try and do is by forging a JWT as somebody else, they could change the permissions, change the email, change the password, or even delete an entire account, even if that's not something that the original user wants to do. So the signature that every JWT has a signature on as well, which means that it's coming from the exact source. And so this is going to be using that encryption idea we talked about earlier, which means there's a public key, private key pairing that has already been created using the data, using whatever backend service you're working with. And that pairing will allow the database to verify whether this JWT is actually coming from the right place or not. All right. So JSON Web Tokens you're going to use, yeah. Go ahead, Tira.
Yeah, I mean, it's like, oh, never mind. I thought that was his last slide. You have one more. Never mind.
Yeah, I have one more. So I talked to you guys a lot today about token-based authentication, and so JWTs works very similar to cookies, except that they literally just go in a different section of your HTTP request. Your HTTP request has a cookie section and it has an a header section, which is usually for the authorization. And so your authorization header will usually be full of a dictionary, a JSON dictionary for your JSON web token, or you can use cookies on the web, and there's a cookie section in the HTTP request for that. But there's really more of a thing of preference. It's not a lot of pros and cons versus one versus the other, but they're both token-based authentication. There's one other kind of authentication called session-based authentication, which is older than token-based authentication and is not recommended anymore. So I want to preface all this information. You don't have to read all this, but I'm going to preface all this information by saying token-based authentication is what we recommend and what is generally recommended, because session-based authentication is not as efficient, and it takes a lot more memory. So what is session-based authentication? Session-based authentication is it makes the server keep in in non-persistent memory what's like any kind of session at any moment with the user, and it will include all of the session data that's going on for a user for as long as the user is logged in. So what that means is that for every single user that's currently logged into a service, the backend will also have some kind of memory object associated with each of those logged in sessions and continuously keep them updated for as long as the user is logged in. What that means is when you have like a ton of users, and if they are all logged in at the same time, then your server is going to be having using a ton of data to try and keep track of what all is going on at the same time. And so obviously that's not very scalable at all, because if you have all of your users and for some reason you have an event, a promotion, or something going on, they've all logged in at the same time, you are now using like every single possible a bit of data you need on your back end to keep track of all the sessions that are happening. And then additionally, you were trying to manage all of your HTTP requests that you're getting for your backend service and handle all your database calls and things like this. And so session-based authentication is not very scalable compared to token-based authentication, because token-based authentication keeps all of that data, all of the current session information on the client side. By making the client store the access tokens and refresh tokens, it makes the client keep the data that's important for the session. And so that way, if you ever clear your browser cookies or things like that, you have to re-log into all of your stuff. That's because of token-based authentication. With session-based authentication, you have to store all that stuff on the server side, and it's not scalable. Is what the really important part is here. Okay. Before we get into Tiago's Firebase demo, does anybody have any questions? Because I know I covered a ton of data, like a ton of stuff without like it being super realistic. It's pretty conceptual. Okay, solid. Then Tiago's going to show us what it looks like in the real world.
Yeah, I actually do want to do the Firebase example, but I also want to show how we do it right now. So I'll go ahead and do the demo for both of these. Well, not the demo for this one. I'll just, I'm not going to write any code this time. I'm just going to go over the code and show you guys like what does what in our sign up and login, right? So I'm going to mostly go over the authentication part here because I've like worked with this a lot. We don't actually use like, Jonathan, this is like, we don't even use this in our project, for example. This is just part of the clone that we, part of the code that we cloned from the repo, the TPO backend repo, right? And Jonathan used some of this code to do swipe me in, and we don't use a lot of this, but we do use all of this stuff for our project currently, right? And I want to go over a couple of these authentication functions with you guys, and so you guys can see. This is really a really good way to see how these things really work, like under the hood, and how how Amazon and Google, this is part of what they do in their services. But the reason that a lot of people do use their services is that they're 1,000 times more tested than this, and they're you know, they're they're very, very like secure and fast and all the good stuff. Okay, so I've written quite a few Lambda functions with you guys already, but here's how most Lambda functions start. They have a post, right? We're gonna have um, a sign up, and we're gonna read the event body, right? And this event body is probably gonna give us what? It's gonna give us our email. It's gonna give us our password, and all the different things that we want to give in a sign up, right? So the first thing that we want to do is check if our user already exists in the table. So we're gonna try to get item with that email, right? Now, if we are actually able to get item with that email, then that's no good, right? That means we actually got an existing email, so this user already exists. So we want to instantly, as soon as we return something, any function in Python, the function terminates and you don't keep running it. So we will return an error that will, and this will return, I think, a like 401 for, I think it's like a 401 error to our front end, and then you can interpret that however you want, right? But you typically just interpret not 200 instead of like 401, 402, 403, 404. You just interpret if it, you're going to return it, it's not going to be a 4 or 200, and you're going to do something in the front end. For Cloud Care, for example, we show a red message like, hey, user ready. Either we show either user already exists or email or password is wrong, right? I would show that right now, but I have another project running that for the Firebase demo, and it's kind of a pain to like switch between projects. Okay, now if we run this is valid email on our data and it's false, we also return invalid email. And what does this do? This simply applies a regex to our to that email, right? So I mean, I'm not gonna come here and tell you guys that I know exactly like how how like what every single one of these things do, but you can just Google email verification regex, and essentially what this does is make sure there is a at somewhere in that. There's an at somewhere in there, and make sure there is a period somewhere in between the at, and there is a letter in each side of the period after the at, and there's also a letter before the at. That's essentially what this does. It just makes sure your email is not crazy, right? It makes sure it has an at in it because there's no emails without an at. So yeah, so if it's not valid, then we return invalid email. Then we start now storing things that we might want to upload to our database as soon as the user signs up, right? So we will get a timestamp of the time the account was created. Is this useful? Sometimes. It's also, I mean, it's just always nice. It doesn't cost a lot of extra money to just store an integer for the time that the user signed up. So why not? Let's just do it, right? And this is basically that time just gives you like, I think it gives you like however many hours or minutes, I don't know, have been since like 1970 or something. But it's easy to interpret this. And then here's where all the heavy work's done. We will do SHA-256 takes care of hashing and salting our password. SHA-256 is library, and this right here, PBKDF2, SHA-256 takes care of salting and hashing our password, and it's a nice library in Python. As you can see, we can just import it from over here, right? And we can use that to salt and hash our password, right? So which means whenever we go and we log in, what do you guys think we're going to have to do? We're going to have to go backwards in that function. Well, not backwards. We're just going to have to, I mean, I'm not sure like exactly like how essentially we're just going to call the same library, and we're going to try to read the password, and we're going to check it with that, right? And you can only do it with, only them know what exactly is done to salt and hash the password. No one else knows, or else it wouldn't be secure, right? Okay, now if in the case of my app, if our user is a patient, we want to create a user item with patient. And if we want to, if our patient is not a, if our user is not a patient, we want to create a user item with doctor. And what this does is essentially, pull things from our object attributes over here, right? Our doctors have email, first name, last name, hospital, user type, password, hash, time period, doctor name. And our patients actually have the date of birth, they have their doctor email, and they have a plan, right? So it's just a nice way to pick up what attributes each one of our users has. One second. Okay, let's go back in there. Now, now I print this just for debugging, and I'll go ahead and put that in my table, right? And I'll also make sure I don't return our password in our, because I'll end up actually returning our user item object through the HTTP response, but I don't want to have our password in there because our hidden attributes, as you can see, um, is pass hash, right? So we will clean this. We will delete our pass hash before we return this object because we don't want it just flying around the cloud unprotected, because that's not good. And we will issue it a token string, and we will make our response. Does anyone have any questions for this sign up method? Okay. Let's go move on to the login, right? Um, so we will have to log in. Once again, we will read our event body, and our event body should now have our email and our password, like always. And if our email is not in our data or our password is not in data, look how nice Python is. It just reads out in English, but yeah, if our email is not in data or password is not in data, then we will return an error that we either don't have the email or we don't have the password, and we'll just terminate the function, right? Now, we will once again check if the user exists already, right? Now, remember how before, if it existed, that's an error. Now we're in login, it's the other way around. If it does not exist, then that's an error because we either got we got the email wrong, right? That's not good. Now, we will do this because we probably wouldn't have to do this if we somewhere did this better, because that means like the outside, we can just we're just unpacking the map right now has an item that points to our user object, and we actually just want the user object. We don't want the whole map, the dictionary, I guess. So we just do this to index in there. Now we'll verify our password, right? And we will verify with, once again, that library dot verify, which is the method that checks the password, and it will check our password input and so it'll check the password input, right? The password input is actually in not salted and not hashed, right? It's just maybe 1, 2, 3, 4, 5, 6, 7, 8, which is my password for most of the accounts that I do for developing, and it'll test that against a hashed and salted password in our database, right? Which looks something like, looks something like DynamoDB. Looks something like this, right? Can you guys read that? Probably not. I would hope so. They can't read that. It'll test out one of these against whatever password you put in, and it'll tell you if it's correct or not, right? Now, this is a boolean, right? This should return a boolean. I can't go into it right now, but this returns a boolean, right? So password correct will set to true or false depending if the password is right or not, right? And then we'll once again do this, and then if the password is correct, right? If the boolean is true, then we'll return a certain response, which is a 200. And if it is not true, then we will return false. Sorry, we will return not 200, right? So I think that is pretty straightforward. Do you guys have any questions about that? No? Okay. Let's move on to Firebase authentication, which is one of the built-in authentications that you have. Um, One of the built-in authentications that you have for by Google, and it does all the work for you. And you guys will see, right? We have how many lines of code written just to so this is 120 lines of code just for sign up and login, no authorization, which is a bunch of stuff, 100 more lines here. And the front end, you have to do a bunch of work. You have to, I don't know, make the data look all nice so you can call these functions and stuff. Now you'll see how nice it is to do the other way. Now, this is my work project. Please don't tell my employer that I'm showing you guys this. It's a top secret information here, but they won't know. But anyways, this is the authentication file that I have for my project Serrano. I don't know why my camera turned off again. Let me turn it back on. There you go. As you guys can see, there's simply 90 lines of code and with comments, and I could honestly have 50 lines of code. I just have a bunch of I just have a bunch of like prints and um, yeah, one print. I have prints everywhere because I was working on this a couple weeks ago and I was debugging it. So I could honestly take off these prints and it would be, and the comments, it'd be like 50 to 60 lines of code, and this is incredibly nice. So this makes use of Firebase's of Google's plugin for Flutter, and it's called Firebase Auth, and it does literally all the work for you, right? So where should I start? Let's start with our register method, right? So this literally, you guys see this right here? This does all of the work. This does 100% of the work. If you just call, so the very beginning of my class, I created auth equals firebase auth.instance, right? Right. So on this auth object, I can literally call create user with email and password, and it'll actually create a user with email and password if you just give it the correct the email and the password. And it's crazy, but it literally does work, and it's fantastic, right? And um, I'll create a user from that result, right? That result will return me a user, and I can print that, right? And now I could be done here, like if I didn't have email verification. But not only does it have a one-liner for create user with email and password, it also has a one-liner for email verification, right? So I can call user.send email verification, and it will literally send you an email for for email verification. And it's really, really nice. And this email verification email is not the email is not very pretty, but there are ways to customize it and send it from your own email. But right now it comes from weird like project random numbers from Google. And if you don't catch this error, you go right through, and I'll create my database service, which we're not talking about today. But right after that, I'll return if the user is verified or not when I register, which I really shouldn't have to. But I was debugging this earlier. You don't have to do this, but I'm doing it here. Okay. Anyways, and then now our sign-in function, right? So we sign up. Now what we do is we call this function called sign in with email and password. We give the email the password, and if it works, it'll return a user. Otherwise, it'll return null, and it's really nice. Once again, right? It works really, really clean. And I also have a sign in function, a sign in anonymously function, which this application specifically not requires, it allows users to play games anonymously, to join rooms anonymously. So I had to add this feature in. And guess what? We also have a one-liner right here. We call sign in anonymously, and it'll create an anonymous sign in. So let me show you guys what the console looks like for that for these anonymous users. Firebase. I'm opening up it on my second monitor in a second. I don't know why your camera keeps turning off, but it looks something like this. We'll have all these. I have like a 38. Yeah, I have like 38 users right now. That's all of me testing. But for example, we will see some anonymous ones right here. and they'll have a user ID just like any other user, and it's very nicely done. Okay. Now, how do I handle? Oh, we also have password reset. All right, we have a one-liner literally on our password reset, and it's all really convenient. So let me show you guys how I handle this. Right. So how do I handle these changes that happen? So I have these sign-ins, and they don't seem like they really tell our front end what's happening. Right. But we have I have my entire application. I'm kind of getting a little bit into like front end stuff now, but I'm gonna try to keep it as um, sorry, I just got a notification. Let me turn it off. I'm gonna try to keep it as abstract and like as high level as possible, right? Um, what happens is I have my entire application um, wrapped around a stream provider from like which in Flutter literally just hears to our auth service. Basically, just listens to changes in my auth service all of the time, right? Now, as soon as there is changes, like right, so it listens to user, right? And as you can see, we have a get called user, and this will return changes when auth has ID token changes, right? So whenever I do this or this or so whenever I do sign in or create, this will trigger the stream and it'll change this value, and it'll prompt my app to rebuild, right? Um, and essentially what happens, I wrap up my application, and this will get updated all the time, so it works nicely. So if my user is null, I return my authenticate, which my authenticate will flip between sign in and sign on and sign up, right? I can click here, and it's the toggle view. I will toggle between sign in and sign up, and um, and let me go back in there. And what was I before? So I was here, and I was talking about my wrapper. Yep, it's the wrapper. And otherwise, it'll go to home, right? So let me show you guys how exactly this thing really works. So let me go ahead and I was just show you how it is in action. Um, so I have this account, which is me, and I'll delete it. And let's sign up. So, and I'll show you guys the output that happens in our thing here, right? So let's see what our console tells us, or what our terminal tells us. So we'll just make a random username, right? We'll make a email, and this has to be a real email because you can't log in if our email is not verified. Because as you can see here, when I create a user object based on my user, and if the user is not null, and it has to be verified or anonymous, then I'll return a user. Otherwise, I'll return null. And as you guys remember, if I return null, I go to my authenticate screens. All right. So nice. So I'll sign up, and I'll get the message, check your email, right? So let's see. Um, Hopefully, oh, that's not what I was waiting for. Let's see. Maybe I have to reload this. Let's hold up. So maybe this didn't work this time. Let's see. Let's see if we got it in here. We got this in here. Let's see if our email authentication didn't go through for some reason. Maybe it just went through my other emails. Let's see, Firebase. Where's my here? Nope. Oh, I think I just got it now. I think it just took a second. No. Hold up. What's going on? Firebase email. don't know why it's not showing up right now. Because I've done this. I have like 1,000 emails from Firebase when I was testing this. Let's try again. Let's try again. Let's try again. Maybe I typed in my email wrong. I don't know. Maybe I typed it in wrong. So let's reload the application and let's see if it shows up in here. Okay, it showed up in here. Now let's delete it and let's sign up after reloading it. That's not the username. Tiago. Okay. Should work. Okay, I don't know why our email authentication is not working. Let's see. I'm not gonna be. What I want to show you guys is that I'm not gonna be able to sign in if my email is not verified. It tells me to verify my email. So now I'm not even gonna be able to get in the app because I'm not getting the email. I don't know what's going on. Maybe the other dev made a change recently, but for some reason I'm not getting these verification emails. Maybe they're going to my promotions. What's going on? Let me find it. Let me find the stuff. Let me find it. Hold up. Let me stop sharing for a second so I can scroll through my emails without maybe something weird signing up. Okay, there you go. There you go. So this is what the email looks like. You'll get an email from Firebase app, and it'll say, "Hello, follow this link to verify your email address at Serrano, whatever it's called, the app is called." And I should be able to like click on this link, and you'll have like, please verify your email, right? And I don't know what's up with I don't know what's going on right now, because right now it is not sending me the verification emails. I think it's just taking a while. Sometimes it takes like 10 minutes for some reason. I think it's because like we need to pay more money or something to make it faster. I don't know. Anyways, that's pretty much what I want to show you guys, the code behind this. Don't worry about the emails like not coming through. I'm not sure. I think I'm just gonna get them delayed. But it really is as simple as having like send password, reset email, create user with email and password, sign in with email and password, and Mayo couldn't come. Okay, and what is the other one called? Send verification email. Yeah. So I mean, it's the the story here is we can do our in-house login and sign up, but there's also all these cool services that we can take advantage of that are very well built, and they have one-liners that, behind the scenes there's probably like 200 lines of code that do each of these methods, but in our side of the things is just a one-liner, and we don't have to worry about it because someone else did it for us. And at least for Firebase, is also free, so it's like really hard to turn it down. Do you guys have any questions for that? Oh, there you go. Yeah, okay. It was just taking a while, guys. I'm not going crazy. I got it 4 minutes ago. It was just taking a while. So, okay, I'm not going crazy. I don't know why it took a while this time around. Maybe my email just wasn't updating because I got it at 4:42. So it's really, really weird that I got it so late. So let's try it one more time. I think I don't know why it's taking a while right now, but trust me, it does work, and it is nice. Yeah, I'm not sure exactly why it's taking so long. Oh, I just got it. Okay, I don't know what was going on, but here's what it looks like. Your email has been verified. You can now sign into your account. Right now, I will sign into the account, and I will log in. And as you guys can see, I'm logged into the app, and I will show you guys what it looks like in the terminal, right? What happens is we have our notifying ID token listeners about the user. So as soon as we sign in, it will notify the ID token listeners, which are this is basically our listener, the stream, And as soon as our stream listens about this change, it'll rebuild the entire application because we have it all wrapped in a listener for my user, right? And it'll do that, and it'll rebuild the thing. And as you guys can see, the email is verified, and these are all the different variables inside our user. It has our it has is new user, false profile, provider ID, username, and it has our email, it has our phone number, photo URL, and UID refresh token that just talked about, and our UID. So it has a lot of data that maybe we don't need to know if it's a new user, but maybe we want to implement this feature. But hold up, Google already did it for us. So if we do need it to add a feature for new users eventually, then we don't have to add it. It's already added in. So that's why basically it's really nice. And also, I didn't show you guys, but the logout is also a one-liner. And sign out. You literally just do auth.sign out and you're done. I mean, literally that's it, because you don't have to have any of this try catch. I just have it here for error handling. But all you'd have to do is just say return await auth dot sign out, and that's all the code that you need, right? All of this is just like extra for error handling, but the meat is just in one line. And if I click sign out, then I get out of here, and I can also go around in here. And as you guys can see, when I sign out, it'll notify the ID token listeners and the auth state token listeners. And if I sign in one more time, also, let me show you guys the forgot password. If you do this, it'll submit an email. This is just basic front end. This is actually not done yet for this specific part, but maybe the email will take a while this time as well. But I will get like a forgot password email eventually, like this. Oh no, this is the verify email address. Okay. Anyways, they have very similar forgot password like email resets for this, which is all really nice. But I think that's all the things that that I had for you guys. Do you guys have anything to add? Any questions? If not, I think this is it for today. Thank you guys for coming, and have a good rest of your weekend.
Yeah, this really helped. Thanks.
Yeah, you're welcome. It was nice to we enjoyed doing the lecture.
Mhm.
All right, thanks y'all. Eric, can you end the lecture so we can get the recording? Oh, Eric's talking to my roommate. Let me go tell him to end the lecture. But I